Did I put the wrong one? There we go. Okay, we're recording now. Yay. Okay, so we started a little early this time, but that's okay. The first focus activity for the second 6 weeks. So next week you'll get the second one, and in a couple of weeks you guys will turn those in, just like we did yesterday. However far we get, and that'll be hopefully a good quiz grade for you. So as we move on to the inverses that we were talking about yesterday, and you'll have to remind me as to how far we got. But before we get to there, just a couple things. There was an email sent out earlier just to let you know in your 8th period class today, we are going to have a fire drill. Okay, so just go ahead and let you know they're going to go ahead and do it about 3:50. So this is one of those times where, when you go, you'll take all your belongings with you, because then when you get out to the sidewalk, you're just going to go ahead and keep going. Okay, we're not going to worry about coming back in the building. So just kind of a heads up on that. Tomorrow we are going to take the district assessment. And we talked about the bonus points that's tied in with that. If you're able to get a 60 or above, I'll give you 10 points on the previous test, or if another grade is low, I can take a look and see what will help you the best. But we are going to go ahead and try to stop a little early today so that you can start it, because we do need to have that finished for tomorrow, because it's for the first 6 weeks. But that's what we have going on as far as class time. Tomorrow morning at 8:05, that is the deadline for what? Okay. We took it on Monday. The exam. So if you are wanting to come in and retake, and I think I've had a few people so far come in and do so, tomorrow morning will be the last time. And then next week, we'll go ahead and spend a couple days on factoring, and we'll finally get into trigonometry. Okay. Any questions as to what's going to be happening? No. Hey, Andrew. That's their idea. Now, they think that the next one's going to be held in October. I was actually asking Mr. Stewart about this yesterday, because one of my students said that he's at Chapman quite often, and nobody's talked to them about what the procedure is over at Chapman. Is that the case? How many people go to Chapman for some of that? Have you guys been talked to about what happened if anything occurs over there? Okay, that's weird. Okay, but the response I got was that you follow the same policy here. We got these 4 items. Okay, lockout, lockdown, evacuate, and shelter. So it's one of those things. I would almost consider Chapman like the dining hall. If something were to happen extremely close to it, if you're able to get away, make sure to call the school, let them know that you're safe and where you're at. Call your parents or your guardians too, to let them know you're safe and where you're at. If there's something happening maybe off Chapman but close enough, more than likely they'll go ahead, lock it down, and find a safe place to go ahead and hold up until everything gets taken care of. But as far as your question goes, I know he told me we are doing it in October, but we don't know yet like what classes they probably won't even choose the classes until maybe a day or so ahead of time. And maybe this time they'll decide, hey, we're just going to go ahead and do the lockdown and not worry about the evacuation yet. But that one is coming. At some point, they do want to get some classes and walk them out with the police and get them to the buses and just kind of let the students see what it would really be like. Okay, good. Any other questions? Nice. Okay. So help me out here. How far did we get this with the mango? Because I remember making the mango jokes. We're on example 3. Okay. So let's see here. So did we finish this up? We haven't started it yet. So I'll tell you what. Let me go ahead and hide that real quick. Just pretend you didn't see that. Okay. Wasn't it this class yesterday that I was showing the Wizard of Oz clip? Yeah, there you go. Yeah. Okay. We're connecting math to everything, and it's so awesome, right? Okay, but before we go ahead and do that, let's go ahead and review just a little bit, because we've been talking about inverses, right? Okay. And you got your homework on this. We may need to go ahead and carry this over a little bit into Monday, and if we do, that's fine. So if we're able to finish it today, perfect. If not, we'll go ahead and continue this on Monday. We should be able to finish, and we'll probably have the homework due on Tuesday. Okay. So let's say we have this function here, and we want to go ahead and do a couple things. First, I want to go ahead and find the equation for k, what I'm calling this upward increasing curve. Okay, so it's the top half of a parabola. What parent do you think this is coming from? Square root. Okay, good, perfect. Now, the square root normally starts here at the origin and curves up to the right. So I tried to draw this as accurately as possible within a minute before the class to get a good problem for review, but what transformations do you notice? Okay, so we shifted it 2 left, so Angel's already telling me the square root of x plus 2, and then what? Plus 1. Again, I'm always forgetting, why is it plus 2? Because we're going left. There you go. You take the opposite with a horizontal translation. When you're multiplying by x, remember you take the, what do we do when we flip the numerator and denominator? The reciprocal. We take the reciprocal. Okay, so this guy here, k of x, would equal the square root of x plus 2 and then plus 1. Perfect. Okay. Now, when it comes to inverses, what are we really doing here with the x's and the y's? We're just switching them, right? The x values become the y's, and the y's become the x's, okay? Just like we were talking about yesterday. Well, you'll notice I've already got a couple of lines here, one vertical, one horizontal. So I'm going to go ahead and grab this vertical here. So let's see. If I move this guy across my graph, is he a function? Yeah, he passes the vertical line test, because remember, this guy is visually telling me if any value of x repeats. Okay, so we know he's a function. Okay, so that's good. Now, this one, the horizontal line test, does anybody remember that little phrase that we're trying to determine? 1-to-1, yes. So what do you think? Would he pass the horizontal line test? Yes. Now, the horizontal line test is going to tell you if any y values repeat. Okay, so because no y values repeat, he passed the test. I know that this guy is a 1-to-1 function. Why is that good news for us when we're talking about inverses? The inverse is what? I'm sorry, I can't hear. I'm old. Rational? Okay, it starts with an F. We put the fun back in it every day. Function, there you go. That's what we want. We want our inverses to be functions. And we saw an example yesterday where we didn't end up with that. You remember we had to leave it equal to y, and we called it an inverse relation? Well, here's the thing. If it is 1-to-1, then you have absolutely no worries. You can go ahead and find the inverse. Everything is good to go. If it's not 1-to-1, we're going to have to restrict the domain so that it is. And we have a problem like that coming up in just a little bit. Okay, so let's go ahead and do one more thing before I find his inverse. What is k's domain? -2 to infinity. Perfect. And that -2 is included. What's his range? How tall is he? I say 1 to infinity. Okay. There we go. 1 to infinity. Now, let's actually go ahead and find the inverse, and then we'll go ahead and sketch him. How do I find that inverse if I have the equation? Okay, now before I start manipulating it, I want to switch the y and the x. Now remember, k of x is just another way to represent y. So I'm going to say x equals, okay, the square root of x plus 2 becomes y plus 2, and then plus 1. So you switch the positions of x and y, and now I solve for y. Okay, so Lilybell is absolutely correct. First thing I got to do is subtract that 1. Okay, opposites cancel. So x minus 1 is going to equal the square root of y plus 2. Okay, I'm going to square both sides. Okay, so I'm going to square this quantity, square the right. Now, what happens if I square a square root? Yeah, they're going to cancel because they're inverses of each other. So that's gone, that's gone. So this quantity, x minus 1 squared equals y plus 2, one thing left. Okay, plus or minus? Now, no plus or minus because we're not taking the square root. I want to subtract the 2. There we go. So I'm going to have this quantity, x minus 1 squared minus 2 is equal to y. Okay. And now here's where you're going to make your decision. Okay, what did we say about this inverse? Was he going to be a function? Yes, he was a function because the original was 1 to 1. If it's a function, I want to replace that y with the notation. Because we called this guy k, I'm going to put in k inverse. Okay.
So 1 instead of a y.
Oh, there you go. Well, see, that was just a teacher strategy because, you know, we have our student teacher over here, and I'm trying to show her how to keep you guys engaged. Do you believe that? Okay. But there you go. Yes, yes, yes. Okay. So if it was not a function, we would just leave it equal to y. So this is an inverse function. But I want you to go ahead and take a look at this one. All right. What is x minus 1 squared minus 2? It's a parabola, right? And we know that parabolas always want to open up wide. So let's go ahead and graph this guy. The minus 2 is going to pull him down 2. The 1, because it's minus, is going to pull him 1 to the right. Okay. So we're going to have something that probably looks like this. So there's the full parabola. Okay. But here's where that domain and range is going to be very useful to us. Now remember, this inverse is going to be already restricted by the domain and range that we started with. For this guy right here, his domain has to be the range of the original function. Because remember, what do we do with the x's and the y's? You switch them, right? Okay. So these x's here, they're going to become y values. These y values, they're now going to become x values. 1 to infinity. Can anybody tell me what the range will be? Negative 2 to infinity. Perfect. Negative 2 to infinity. Now, go ahead and take a look. Compare this domain and range that we know our inverse has to have to the graph we got. Does it actually go for range vertically from negative 2 to infinity? Yes, that one's perfect. But what do you notice about the domain? Okay, he can only exist from 1 to infinity. That's what we started with. Those are only values that we're allowed to use. So even though, yes, this is a full parabola, we have a working parabola here, we have to go ahead and cut half of him off because that's what the domain says to do. He can only exist from 1 to infinity. All right? And see, now I've got that symmetrical graph. In fact, do you remember what's that line that we reflected across? Y equals x. That's that linear parent. Perfect. Okay. Is this making sense? Any questions? No? Okay. All right. Well, let's get back to this guy right here. So now we're going to continue to work with the idea of knowing what the different quantities are. Just like in the previous examples yesterday, we had the cost and the mangoes. Okay. So now we have, suppose W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. Okay. So what does the expression P of 25 represent? So think about your input, what would be an X value versus what you get out of it, the output, a Y value. The function, when you have P, he's going to tell you what? That's going to be the average amount of water in gallons. So let me go ahead and choose a color here. Let's say green. Now what does X represent? It represents the height. So think about this when we're looking at that function. P of 25. What would 25 represent? Would 25 represent gallons of water or height in feet? The height in feet. Because whatever I substitute in is going to be the height, but P of 25 would give me the amount of water needed for a 25-foot tall tree. Okay, so what I'm trying to do is come up with a sentence. I'm trying to explain what the function is trying to get us to think about. And let's see what I put here. The average daily water needed for a 25-foot tall palm tree. Okay. All right. Now, this is one of those times with everybody being, individuals, how likely is it that we're all going to come up with the exact same sentence? Probably not very likely, right? But is there more than one way to say something? Yeah. So, I mean, as long as you're verbalizing and I'm able to understand what it is you're trying to say, you should be fine. Okay. Let's try the next one. Now remember, the function P gives you the water based on the height that you put into it. So now, what does that expression mean? I keep forgetting about the -1. That's the inverse. So what am I going to do with the water and the height? I'm going to switch them. So what does the 25 represent now? That's the number of gallons of water. So the inverse will always give you the height of the tree based on the amount of water that you're plugging in. So is this helping to make it a little more sense? Seeing that we're actually switching those? Okay. And let's see what I wrote here. The height of a palm tree that requires 25 gallons of water. Okay, perfect. Okay. 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 All right. So if you're still a little hesitant, we got some other problems coming up. I mean, problems such as these, their bark is definitely worse than their bite. It's a tree pun. No? So is this stumping anyone? No? Okay, if you just stick with me, we'll get to the root of the problem.
How do you come up with these?
Oh, because I'm Mr. West. Like she's just like, yeah, that tells me nothing. Okay. All right, so I'll stop for a second. In a minute, we'll branch out into something new. Okay. Oh, you didn't know math could be so fun, did you? Okay. Anyways, C, what does the equation, let me go ahead and erase these right here because that was something else. All right. So what does the equation P of V equal 50 tell you about V? So think about what we said for A and B. P gave you what? Was it the height or the amount of water? Okay, P gave you the amount of water, right? Because it's P inverse that gave you the height based on the water you put in. So what would V be? Would that be the water or the height? That would have to be the height. Because remember, the function P will give you the amount of water. So that 50 has got to be what? Okay. So I would say that a tree V feet tall would need 50 gallons of water. Okay. But now, rewrite this equation in terms of its inverse. Okay. So remember, what are we doing with the height and the water? We're switching them. So for P inverse, what should I write? P inverse of 50 is equal to V. And let's see what I said here for my sentence. V is the height of the palm needing 50 gallons. Okay. And what I had there originally, I'll go ahead and write now, because remember, the input, whatever you plug in is your X value. The answer you get is your Y value, right? So the ordered pair V50 would be on the original function. So what would that point be on the inverse? Remember, what do we do with the values? You just switch them. So over here, it should be 50V. Okay. How we doing? All right. Here's our last one. Palm trees are, on average, Z feet high, and a tree of average height requires K gallons of water. So we're still working with the same idea, but we're just switching the variables. We're going to say Z is now the height of a tree, and K is going to be our number of gallons of water. So it says represent this in terms of P and P inverse. Now, once you have the first one, the inverse is easy because you simply switch them, right? But the decision you have to make, am I going to go ahead and say, and don't say it out loud, let's give everybody the opportunity, will I say first P of Z equals K, or will P of K equal Z? Think about what we've discussed for the previous letters here. Okay. Is the function P giving me the amount of water, or is it giving me the height? Give you a few seconds to think about that. Okay. So let's see. How many people think it's P of Z equals K? Okay, so quite a few hands going up. Is there anybody who thinks it's P of K equals Z? Okay, so we have a few hands going up. Let's take a look. Would be P of Z equals K. Because remember, we were told at the beginning, this function P will give you what? Gives you the water. So it has to equal K if I input the height. So its inverse would be just to switch the two. P inverse of K would equal Z, because the inverse was giving you the height. Yes?
P, isn't the height dependent on the amount of gallons?
But see, that's what we're saying, though. We're switching these around so the independent becomes the dependent and vice versa. That kind of makes sense? Okay. All right. Because the x's become the y's. But you're absolutely right. That is the idea. Mm-hmm. Okay, good. Good. And we have these right here. Now, when you see a lot of these, like for example, we've been working with these here. Look at 3 real fast. It says P of Z plus 10. So we're still working off the same idea that part D gave me. But when you see a value added or subtracted to X, what type of transformation does that tell you? Yeah, left or right. You take the opposite, and that tells you how far and what direction to go. You remember we also said it earlier, if you're multiplying X, or in this case Z, by a value, you take the what? The reciprocal. That results in your horizontal stretch or shrink, right? Now, you want to take those ideas of the transformations and just go ahead and put them out of your head when you're dealing with these. We're going to take the values as they are, okay? Now, remember, what does Z represent? Z is the average height of the tree. K is going to represent the number of gallons of water that I need. So the function P, what was he always going to give me? Was he always giving me the height or the water? The water, right? Okay. So let's think about this. This is going to give me the number of gallons I need for what type of tree. What have I done to the height? I've doubled it. So this would be the number of gallons of water I need for a height twice the average height, or for a tree twice the average height. Does everybody see how I did that? Okay. Now you want to be careful. Look at 2. This one says 2 P of Z. Now where's that 2? Is he inside or is he outside? So if he's outside, he's no longer affecting the height. What is he affecting? He's affecting the water. So I'm doubling this function. But remember, the function always gives you water. So what are we really doubling? We're doubling the amount of water needed for a tree of average height. Okay. Now, we'll just go ahead and run through these together for the sake of time. Oh, might help if I have these covered. But that's exactly what I have here. Water for double the average height of a palm, double the water for an average height palm tree. Okay, so we're down to 11 minutes. I think I'm going to go ahead and stop there. I'm going to go ahead and get you guys started on your district assessment. Okay, because we do need to go ahead and finish that tomorrow, and I just want to make sure you have enough time. So we will continue this on Monday. Okay, so your homework will definitely not be due until Tuesday, but you might still be able to go ahead and take a look at it. If you have any questions, definitely